Hi there, and welcome to ML in Minutes. I'm Terry, co-founder of Remyx AI, the easiest place to create custom computer vision applications. Today I'm going to chat with you a little bit about how we use auto-labeling in a feature we call text-to-dataset that powers the Remyx Engine, making it easy for people to get started without having to scrape together a bunch of data or buy licensing for data and create custom computer vision models optimized for their deployment target. First, let's chat a little bit about some of the challenges facing computer vision engineers as they're trying to create custom machine learning applications. Suppose a customer comes to you and says that they're building a robot in a warehouse and they need it to be able to avoid ladders or pallet jacks, things like that would appear. The first thing you might try to do is go look around in the open source. There's an existing model on a model zoo. And so you can go to places like Hugging Face where there's hundreds of thousands of models. But if you were looking to avoid a ladder, for example, or a pallet jack, you might not find a model that's out there that's been trained for recognizing those specific objects of interest. You go look at ImageNet and you won't find these object categories represented. So you can't do things like subsetting a research data set or pulling a model off of a zoo trained on a research data set. Here's another model zoo, the OpenVINO model zoo maintained by Intel, and this would work pretty well if you were trying to create a face filter or something like that. But you'll see that it also doesn't support detecting and differentiating many of the objects that you might expect to in a new computer vision application. So many of these models are adapted to data sets like the Pascal VOC dataset or ImageNet. And these data sets, they have certain image distribution you might not expect to encounter in the wild. And that skew between train and test data is causing problems for people when they try to get a model off of the shelf and deploy it in an application. If you're that mobile robot moving around and in the field of view, you see a shelf, you might misinterpret that as something like a train, and this would be useless. In order to create custom computer vision applications, you typically need to make these last mile optimizations. So it's often true when you're making a computer vision application that you'll need to account for things like the camera perspective or specifics about it, like the color scale or the resolution can have an impact in how the model is going to perform. And you often need to make small models that trade off in accuracy so that they can have the latency required for making real-time decisions on camera feeds. Well, how do we go about building a data set so that we can have the model optimized for our application environment? In the past, I would say do some image search, scrape around, just plugins like the Google Image Downloader that make it easy to get hundreds of images for object categories of interest. You can construct these data sets pretty quickly, and with transfer learning, have a pretty good model for simple tasks like image classification. More recently, much larger web-scale data sets with billions of images and captions are making it possible to create very powerful generators for images that allow you to create image data sets highly specific to what you're interested in from text prompts. Here I have the output of a custom latent diffusion model trained on hundreds of thousands of images, and you see it's kind of low resolution, but I can use image to image with Stability's Stable Diffusion checkpoint to refine the image, making it a little sharper. And then I can warp the image using first order motion models to create a video that I can sample from. So now I have many images that I can feed into techniques like Dream Booth, which make it possible to generate many new novel renditions of an object category of interest based off of just one sample. And after Stability open sourced the model weights for the Stable Diffusion checkpoint, there was an explosion of research applying techniques like low-rank adapters and parameter-efficient fine-tuning alongside techniques like Dream Booth. And so it's typically the case that we want to build these pipelines that we can use to create and generate and extract more structured information out of image data sets for the purposes of training new models. Stable Diffusion is good at generating object-centric data sets, and so these class-agnostic segmentation models like U-squared net are pretty good at generating a rough mask for the object of interest. One of the challenges with using class-agnostic segmentation models like U-squared-net is it's not very controllable, and it doesn't work so well in really complex scenes. So we started looking to models like layout to image, where we would have a priori knowledge of where the object categories are based on where we set the bounding boxes before we even generate the images. But these techniques are a little bit slow, and they're still limited in the kinds of objects that they can reliably generate. So in order to support practical computer vision workflows where we need to train object detectors and segmentation models so that we can do spatial computing and have more information about where an object of interest is localized in the field of view, it was important for us to look at techniques like GradCam. And you see how these techniques provide something like a heat map where you can have confidence that the object of interest is well represented, but it's still kind of coarse. It's weak information that we might want to improve upon further. And here's another technique that's using CLIP to try to identify regions of interest associated with the terms that you use. So you can use text and visual prompting in order to find the localization information for the objects of interest in the image. Here's some research put out by NVIDIA earlier this year that uses transformer attention maps and is able to then refine those to get a tight mask for creating data sets and doing auto labeling. So later in the year, Meta released SAM, which is a segmentation model, and it's nice because it's class agnostic. So here, pretend that this was an image that we had just generated through latent diffusion. What we have is a salad, and you can imagine some context where you need to get a mask so that you can mask away the background. For example, maybe it's a robot that needs localized information about what's on the plate. And if this were a salad and we used GradCam to then look at the activations for a classifier that could differentiate this salad from other things, you would think that the heat map is going to be peaking somewhere in the middle of the image. Like, let's say it's around this spinach. If I click it with SAM, it's going to be very fit to that leaf that I just put a point down on. And you can see how SAM with one point alone, using something like the peak of a GradCam heat map, would not be very good at generating a mask for the entire salad. But if instead I considered the heat map as a distribution and sampled points from it, I might end up with another point over here. And if I considered a third point, I might be able to recover the mask for the entire area of interest with something like 3 points sampled in this way. And so that's what we've used for this pipeline that allows us to go from images we've generated from text prompts down to strongly labeled data that we can use to train image classifiers, segmenters, detectors. So this feeds into the Remyx model engine to construct data sets. We meet the user at the level of describing what they want from the model with high-level text prompts. Our agent is able to get the information, the context necessary for creating the model and deploying to the specific target, and then generate the data set and use AutoML to create the model artifacts. And so here's the Remyx Model Zoo, where we feature some of the models we've created with our engine. You see we have a lot of models that are specific to a context you might want to deploy, and they are optimized to consider objects that you might realistically encounter in those settings. So if you're looking for a model and you're trying to make a new custom application, try the Remyx Model Zoo, or sign up and try out our engine where we can construct data sets for you on the fly, optimized for the computer vision task you have in mind, using state-of-the-art techniques and no data required. So that's all I have today. This is Terry of Remyx signing off. Feel free to subscribe to this channel or follow our newsletter, and to try the engine where you can get a custom machine learning model in minutes, not months.